inequalities that include or. So we've talked about and is an intersection where they overlap each other. And generally when we talk about and, we're starting with two sets of numbers. And since we're talking about where they intersect, we're talking about a smaller set when we're done. Let's talk about or. Compound inequality containing or is true if at least one of the inequalities is true. So it doesn't have to be that both are true at the same time. It only has to fit one or the other to be part of the solution set. Its graph is a combination of both graphs. This is called the union of the two graphs. So I'm taking the two sets and I'm putting them together. So again, if I go back to my silver team or band, if we made an announcement in the morning and said, if you are on the silver team or you belong to the band, please report to the auditorium, we would have a pretty full auditorium. We would have all the silver team students. They would all go to the auditorium. We would have all the band students. They would all go to the auditorium. We would still have this group of people that were both, so they're going to show up either way because they're part of both, but we would have a lot of people. When we talked about the and, we kind of narrowed it down to a small group. When we talked about the or, we're including everybody. You can be this or you can be that. Come on down. We've got a huge set there. And if we think about our roads in our town, if I said to you, please meet me at East Street or Main Street, I might get a little confused because there's a lot of East Street and there's a lot of Main Street and I'm not sure exactly where you want me to be. That kind of leaves me confused because you haven't made it a small set for me to figure out what you want when you say or. Let's look at this as far as algebraic inequalities. Solve 4k minus 7 is greater than or equal to 25, or 12 minus 9k is greater than or equal to 30, and then we're going to graph that solution set. So I'm going to solve each of these inequalities independent of each other. So I end up with k is greater than or equal to 8, or k is less than or equal to negative 2, but I want to boil this down and see what this really looks like on my number line. So k is greater than or equal to 8. Here's my number line for k is greater than or equal to 8. K is less than or equal to negative 2. Here's my graph of that solution set. Remember, or, everybody gets invited to this one. Everyone is included. So I'm going to take both of these graphs and include them on my final graph of the solution set for this. So I'm going to include both of these sets in my final solution. So in set notation, k such that k is greater than or equal to 8, or k is less than or equal to negative 2. So this is what my final set looks like. With and, we could have combined them together and put it into kind of one long compound sentence of an inequality. I can't do that with my or, with my union here. I have to write it out as both. I can't really boil it down to one sentence. All right, let's keep going. Solve a plus 1 is greater than 4, or a minus 1 is less than or equal to 3, and then we're going to graph that. So again, I'm going to solve both of those inequalities. I get a is greater than 3, or a is less than or equal to 4. I'm going to graph both of them and see what they look like individually, and then I'm going to combine those two sets in a union to come up with the solution set for the compound inequality that we started with. So notice that a is greater than 3 starts at 3 and goes to the right. A is less than or equal to 4 starts at 4 and goes to the left. When I merge those two together, I actually end up with everything on the number line. So what I end up with is a number line that has everything graphed, and my solution set A, such that A is a real number. So if you pick any real number, it's going to work in one of these or the other of these. So it's kind of like saying, if you are in house 1 or you are in house 2, please report to the auditorium. Everybody's in one or the other. We've included everybody, so everyone, that would be a really big mess if all of house 1 and house 2 reported to the auditorium. We've got anybody in that school belongs to one of them, come on down. Now we're going to take a look at starting from the number line and backing up and coming up with a compound inequality to represent the number line. Can you discern which ones are ands and which ones are or? Write a compound inequality for each graph. So here's this graph here. You'll notice it's a small segment of the graph. It definitely has two boundaries to it. I've kind of included just that small bit here. So this is going to be an and. I'm definitely excluding pieces of this graph. So my inequality to represent that graph would be x such that 5 is less than x is less than or equal to 9. I've got my two boundaries of my end boundaries of 5 and 9, and I know that x has to be in the middle of them. Notice my inequalities are facing the same way. Whenever I write a compound inequality in one sentence like this, those inequality symbols should be facing the same direction. Let's take a look at this last one here. I have 3 as an open circle, and I've got solutions to the left. I've got 5 as a solid circle, and I've got solutions to the right. So this is an or. This is an or. I'm really not kind of excluding it. I'm excluding this little part because it's not part of either of the original sets here. So I've got two sets going on. I've got x is less than 3, and I also have 4 is greater than or equal, x is greater than or equal to 4. So I'm going to include those two. Oh, I forgot the end of my second bracket there. X such that x is less than 3. Here's my less than 3 as part of it. Or x is greater than or equal to 4. So that's my second part that I've included here. Writing those again both in set notation. So I should be at this point able to solve that or, but I should also start to be able to recognize a graph and tell whether it came from an and or it came from an or.